Hello friends, today I'm going to show you how to solve Legendre's homogeneous differential equation. And before we start our lecture, let me tell you one thing. To better understand, please watch all those videos made on the topic linear differential equations from lecture 1 to lecture 13, because this is going to be lecture 14. To understand this lecture 14, you must watch all those videos from lecture 1 to 13. And if you have any questions, any differential equations that you can't solve, then you can send me the message. You can send me the question, and this is my Insta ID ozalekajit123. So I'm going to help you. So this is the form of Legendre's homogeneous differential equation, where a, b, a1, b1, those things are constants here, and f of x is a function of x. So before we solve this type of equations, we need to reduce these equations to this should be reduced to linear differential equation. How to reduce it? First, let me discuss those how to reduce these equations. Then we will solve problems. Okay, so here let me write one thing. Here a, b, a1, a2 an are constants, and let me take this is as equation number 1. This equation is equation number 1. Now let us consider this a plus bx as e to the power z, a plus bx as e to the power z, and which implies z is equal to log of a plus b x, and here e should be the base, right? And this is suppose equation number 1, right? This is suppose sorry, not 1, this is equation number 2. And so we don't need to give here equation number. So let us differentiate it. Dz by dx, let us differentiate with respect to x. If you differentiate it, now here you say this is function of functions, log of a plus bx. Suppose if you have to differentiate d with respect to x, if you need to differentiate log of f of x, it is function of functions, then what you will get? 1 by f of x, then again derivative of f of x, right? So that's why derivative of this will be 1 by a plus bx, then again derivative of a plus bx, and derivative of a plus bx is nothing but b. So that's why we can write here, what we can write, the final result is b by this. We can write this way. So hope you have understood this. So let us take this one as equation number 2. We are going to use this later again, right? Now let me scroll down the page. dy by dx, and remember one thing, this differential coefficient d by dz, this one should be represented by capital D here. Okay, not d by dx, d by dz. Okay, derivative with respect to z will be represented by capital D here in this case. Okay, now dy by dx, it can be written as dy by dz and dz by dx. So we have already got dz by dx. This is dz by dx put here. So then what you will get? Then you will get dy by dz, and dz by dx is nothing but b by a plus bx. That's what you will get, right? So now from here, what you can write, this implies, let me write here one more thing. This is suppose equation number 3, and this implies a plus bx is dy by dx is equal to b into dy by dz. This can be represented by capital D of y. D means d by dz, right? Now what if you have second order derivative of y with respect to x, then it can be written as d by dx of dy by dx. So dy by dx, so from equation number 3, so dy by dx is this. So let us replace this by this value from equation number 3, and then what you will get, d by dx of dy by dz into b by a plus bx. So from 3, so here we are going to use the product rule. So we are going to consider this one as u and this one as v. So u is the first function, v is the second function. We know the product rule, u dot v, its derivative is given by first function u, derivative of the second function, that is derivative of v, plus v, derivative of first function, that is derivative of u. So let us apply this here. So if you apply this here, so our first function here is, first it implies, so our first function, that is u, is in this case dy by dz, then derivative of b by this one, a plus bx. So how to differentiate it? If you differentiate it, then what are you going to have, right? So you see, if you differentiate these things, b by a plus bx, then you will get minus b square by a plus b x whole square, right? You're gonna have this. So let me use the curl bracket, right? So you will get this. So I hope you know how to differentiate it. So what we're gonna do, we are going to consider this, we are going to assume this b as constant, and we are going to assume a plus bx as variable. This is s, okay, let us consider as x, and you know derivative of 1 by x is nothing but minus 1 by x square. So in this case we will get a plus bx whole square. Then again here you see it is not only x, it is a plus bx. Again you need to differentiate this a plus bx. Derivative of a plus bx with respect to is nothing but b, right? And b into b is b square. So hope you have understood this. So that's how we can differentiate, right? Just let me show you here. And derivative of 1 by f of x is, remember, this minus 1 by f of x whole square and derivative of f of x, right? So here our f of x is nothing but a plus bx. So this one b is here constant, so we can write here b. You can imagine b here, suppose we have b. So in this case our f of x is nothing but a plus bx, right? So let me scroll down. Here you see, so derivative of this d by dx, derivative of b by a plus bx will be, according to this, minus b by f of x whole square. It will be equal to minus b by a plus bx whole square. Then f dash x means derivative of f of x. Here that means derivative of a plus bx. And now if you differentiate this a plus bx, then this gives b, right? If you differentiate this, a is constant, b is constant. If you differentiate bx, then you will get b, and derivative of a, that is constant, which is going to be 0. So that's why our result will be only b in this case. And here you see b into b, you will get b square. So b into minus b, this is minus b square, and here the denominator is a plus bx whole square, this is the result. So hope you have understood how we have got this result. So now let me clean these things. So okay, now you see, so this part is done, u v dash is done. Now v u dash, so here u is dy by dz, so v is b by a plus bx, b by a plus bx. And how to differentiate dy by dz with respect to x? So d by dx of dy by dz, so it can, this d by dx can be written in this way: dz by dx, d by dz, right, and dy by dz. So then what you will get from this d by dz, dy by dz, that gives so then we will get dz by dx and second order derivative of y with respect to z, right, we will get it d2y by dz2, right, we're gonna have this. So we have got dz by dx, then second order derivative of y with respect to z, that's what we will get. So hope you have understood this. Now let me clean this. Now again you see, dz by dx, so you can replace this dz by dx by this value, right, dz by dx from equation number 2. If you use this here, this equation number 2 here, then what you will get? So dz by dx, that is again b by a plus bx. So if you put there this one, and there is also b by a plus bx, b by a plus bx into b by a plus bx, that's going to be whole square, right? So what using this equation number 2 we will get, so we are going to use this equation number 2 here, and using that equation number 2 we will get dy by dz minus b square by a plus bx whole square, right, then plus b square by a plus bx whole square, second order derivative of y with respect to z, that's what we will get. And it can be written as d square y dx whole square. We can take this term common, and negative terms, first let me write the positive, then let us write the negative. So then what you will get, b square by a plus bx whole square, then you will get second order derivative of y with respect to z minus dy by dz. So you will get this. Now here you see one more thing. So we have already mentioned that d represents d by dz, right, we have already mentioned that. So these results become, so we can write this numerator on this side, right, sorry, not numerator, denominator, a plus bx whole square. So let us write on this side, then b square, so we can write d square minus dy, and this is nothing but b square, d is taken common, then d minus 1 into y. So that's what we will get. Similarly, a plus bx whole cube, third order derivative of y with respect to x will be b cube d into d minus 1 d minus 2 y and so on. Therefore a plus bx whole to the power n and derivative of y with respect to x will be equal to b to the power n d into d minus 1 d minus 2 up to dot 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 d minus n plus 1 y. That's what we will get. And if you substitute those values in equation number 1, if you substitute those values of this and this in equation number 1, then this equation, this Legendre homogeneous differential equation will be reduced to linear differential equation, right? If you substitute those values in equation number 1 or putting those values in 1, it will be reduced to linear differential equation. Then we can solve such kind of equations as we did, and how to we have already discussed how to solve linear differential equations, isn't it, in previous lectures. So watch all the videos whose links are given in the description box from lecture 1 to lecture 13. So hope you have understood this. Now let me take a question how to solve. This is only this part till now I have shown that explains how this equation can be reduced to linear differential equation, okay, not how to solve. So in order to show how to solve such kind of equations, I need to take an example here. Okay, let me take a question. Now suppose we need to solve this equation, this differential equation. So here you see we will compare this term with this first term with a plus bx second order derivative of y with respect to x, right? And this is nothing but it is equal to b, sorry, here it should be square, a plus bx whole square, so b square d into d minus 1 y, right? So here in this case value of a is 1 and value of b is also 1, so that's why b square will be 1, so we will get d into d minus 1 y. So before that what we need to substitute, instead of a plus bx we have here 1 plus x, so it should be replaced by e to the power z, and which gives z is equal to log of 1 plus x, right? And from here dz by dx is 1 by 1 plus x. That's what we will get, right? So let me take this as equation number 1, and here you see similarly this term dx 1 plus x dy by dx, it can be compared with a plus bx into dy by dx, which is nothing but b into dy, right? B into dy. So then this equation number 1 will be reduced to d into d minus 1 y. So this first term reduced to this. So here b square is nothing but 1, as here you say this one can be considered as a. If you compare this one a plus bx with this, then you will get b is 1. So that's why we have got d into d minus 1 y, right? And these terms will be equal to b into dy, and b is 1, that's why it becomes dy only, right? So that's why we get plus dy. Then we have y. Then in the next, on the right hand side, 2 sine log. So 1 plus x we have considered is e to the power z, so it will be e to the power z. So hope you have understood this. Sorry, we can write this one here. You see, z is equal to log of 1 plus x. So here log of 1 plus x can be replaced by z, right? So now it's become easier. So now if you simplify this, then what you will get after simplification of this, you will get d square minus d plus 1 y 2 sine z, and here plus the minus the gone, so d square plus 1 y 2 sine z. Now this is linear differential equation. Okay, so this is now in this form that we have already discussed. F of d y q of x. Sorry, here in this case it is not x, it is z, right? So q of z we can write, and here d represents not d by dx, d by dz. Okay, so that is the different only difference here. So now let me scroll down the page. So here we have got f of d is nothing but d square plus 1. So our auxiliary equation procedure is same as we have done in previous lectures, right? From here, f of m is equal to 0, that implies d square plus 1. Sorry, when you write f of m, so it will be m square plus 1, d should be replaced by m, is equal to 0, who is equal to m square minus 1. Minus 1 is nothing but I square, right? So therefore m will be plus minus I. So we have got two roots here. M1 you can consider this way, and M1 is positive I and M2 is negative I, right? You can, so you can compare this positive I with, alpha plus I beta, and you can compare this negative I with alpha minus I beta. If you compare with that, then you will get that alpha is equal to 0, beta is equal to 1. Sorry, beta is equal to 1, right? And these are complex conjugate roots. So in case of complex conjugate roots, so to solve this kind of equations, we need to find CF and we need to find PI. So their sum is the solution, right? Their sum is the solution. We know that. So how to find the CF if the roots are complex conjugates? So if the roots are complex conjugates, then CF is given by e to the power alpha. So instead of x, here we are going to have z, okay, right? Because we are taking d as d by dz, right? That's why e to the power alpha z. So now here you see we will get then c1 cos beta z, right, plus c2 sin beta z. So here you see beta is 1 and alpha is 0, and e to the power alpha is 0, 0 into z, that's going to be again 0. Anything to the power 0 is nothing but 1. So our CF will be this, CF will be equal to c1 cos beta is 1, so we will get cos z, and c2 sin b is 1, beta is 1, and z, right? So that's what we will get. Now z is nothing but log of 1 plus x. So you can replace the z by log of 1 plus x. So that's why c1 cos log of 1 plus x plus c2 sin log of 1 plus x. So here we have got this. Here it is written, you see, z is nothing but 1 log of 1 plus x, right? So we have got CF. Now we need to find the PI, right? We need to find the PI. So here you see how to find a PI. So what is the term on the right hand side? Depending on that, the method is different for different form of this. Okay, this is nothing but QZ here. So depending upon the form of QZ, so we apply different methods to find the PI, right? So here QZ is 2 sine Z in this case, in this equation. So here Q of Z is 2 sine Z. So we have already studied that when you have Qx is equal to sine x, then Pi is given by 1 by f of d square sine ax. Instead of x, let me take sine ax. A is constant here. Sine ax, that is equal to sine x by f of d square. So d should be replaced by minus a square. If f of minus a, if f of minus a square is not equal to 0, only this case is possible. Now here you see, instead of sine ax we have z, so that's why this x should be replaced by z. That is the only different here, so remember that. So, and this result is possible when f of minus a square is 0, right? Sorry, if not equal to 0, if this is not equal to 0. Now what if f of minus a square equal to 0? Then if f of minus a square is equal to 0, then pi should be, then this pi should be sine a z. So we are not taking x here, z should be taken, f dash minus a square should be taken, and also z should be multiplied here, right? Z into sine a z f dash a square, that's going to be the pi. So before that, let me check if f of minus a square is 0 or not. Okay, so here you see q of z, in this case q of z is 2 sine z, 2 sine z. So we have sine z only. So if you compare with sine ax or az, sine az, then value of a is 1 in this case, right? So that means we have to check if minus 1 square is 0 or not. So f of d, we have got d square plus 1, right? So let us put here, this d square should be replaced by minus 1 square. Okay, remember that, minus 1 square. So square is on 1 only, not minus, not on whole this minus 1, right? So minus 1 square plus 1, that's going to be minus 1 plus 1, that's equal to 0. That's why we cannot take this one as pi. So we have to go for this result, right? So that is why pi should be 1 by f dash minus a square, in this case 1 square, 1 square. Then we need to take 2 sine z, our qx is 2 sine z, and also we need to multiply z here, so z into this, right? So this should be our pi. Let me write clearly. So this is our pi, z into 1 by f dash of minus 1 square into 2 sine z. So that should be our pi. But what should be what is f dash minus 1 square here? So to find that, what we're going to do, first we are going to find f dash d. So we know f of d is d square plus 1. If you find f dash d, then what you will get? You will get 2d, right? You will get 2d. So that's why z dot 1 by, you will get here 2 is d 2 sine z, right? So in order to find this f dash of minus 1 square, we need to put first f dash d. So we have put this, right? This two cancel. So that's why we have got 1 by d sine z. Now remember one thing. So we have to find f dash minus 1 square, we need d square, because only d square can be replaced by minus 1 square, right? So in order to make it d square, so if you make it d square, then d should be multiplied with the numerator as well, and in both numerator and denominator d square is multiplied, right? So that's what we have done. Now z into this d, let me keep it as d, and d square can be replaced by minus 1, and d sine z. D means d by dz, and d by dz of sine z, that's gonna be equal to cos z, right? So our pi is equal to, our pi is equal to, let me scroll down the page, minus z, derivative of sine z is cos z, right? This minus comes because of this minus 1, right? So don't be confused. So now z can be replaced by, value of z is here, you see, this is the value of z, right? This is the value of z, log of 1 plus x. So we can replace the z, you can replace the z by log of 1 plus x cos, again log of 1 plus x. So this is our pi. So this is our pi, and our cf is this. This is the cf. So we have got cf and pi. Adding these two, we will get the result, right? So let me minimize this page so you can see this both cf and pi in one frame. This is our cf and this is our pi. Therefore, what will be the solution? So solution is y is equal to, cf plus pi. So cf, we have got c1 cos log of 1 plus x. So cf, we got c1 cos log of 1 plus x plus c2 sine log of 1 plus x, and we got pi, this is pi, minus log of 1 plus x cos log of 1 plus x. So this is our result. So let me write here properly the answer. C1 cos of log of 1 plus x, then plus C2 sine log of 1 plus x minus, so wait. So our solution is y is equal to C1 cos of log of 1 plus x plus C2 sine log of 1 plus x minus log of 1 plus x and cos log of again 1 plus x. So this is our answer. So hope you have understood how to solve this kind of equation. So if you have understood, please share with your friends and hit the thumbs up button. And if you are new to my channel, please subscribe the channel and help me to grow the channel and inspire me to create more contents. So thank you for watching.